Hey everyone, in today's lesson we'll be looking at two-step experiments. Let's have a look at the first question. Two people out of Ben, Anita, William, Lachlan, and Noreen are to be selected for the positions of the president and secretary in a tennis club. List the possible pairings for the positions of president and secretary. So what I've done here is I've let Ben be the president first, and then these people here are going to be the secretaries, which I've listed out here in the first column. Then for the next column, what this represents is the first person being Anita, who is the president, whereas Ben, William, Lachlan, and Noreen are going to be the secretaries. And then you do the same thing for the next three columns. So you let William be the president, followed by the rest of them being secretaries. Then Lachlan being the president, okay? And then Noreen being the president. So altogether, we've got 4 rows, and we've got also 5 columns here. So altogether, there is 20 pairings. Now in part B, what they want us to find is what is the probability of the committee consisting of Ben and Anita? So Ben and Anita would be BA and AB. Doesn't matter who is president and who is the secretary. So that's a total of 2 out of 20, which is 1 out of 10. Now for part 2, 2 males. Well, if we want 2 males, then that represents where there is Ben, William, or Lachlan. So as long as B, W, and L, okay, then that's fine. But there has to be 2 of them. So what we do is this. If we want B, W, or L, okay, you can list them out really easily by choosing the first pair. That's BW. Okay, then swap them around. That's WB. That's already 2 types of pairs now, where they're the same people, but they just have the different roles of president and secretary. Then you look at the next pair. So W and L, and swap them around. And then there's another 2. And the last 2 in the pair are B and L. And then you swap them around. And then you get LB like that. So there are 6 in total, okay, out of 20. And that's 3 out of 10. Right. Let's have a go at part 3. So part 3 says, what is the probability of a committee consisting of a female president? So if you want a female president, then either Noreen or Anita have to be the president. So in this column, this is containing all the different possibilities where Anita is the female president. This one also is where Noreen is the female president. So how many is that? There is a total of 4 times 2 different possibilities. So that's 8 different possibilities. So 8 out of 20, if we were to divide the top and bottom by 4, you get 2 out of 5. All right. Then for part 4, we want at least 1 female. So if you want at least 1 female, you either want A or N in the group. So obviously these 2 columns where Anita and Noreen are the presidents, they have at least 1 female in there because the female is the president. So now let's have a look at which one has A and N. Okay, so I'm just going to go down the list. If it has A and N there, A or N there, then I'm just going to highlight them. So WB doesn't have it, WA does, WL no, WN yes. Okay, and then these 2, A and N, there we go. Okay, so as long as it has A and N in there, A or N in there, that's fine. Okay, because you either want them to be 1 female or 2 females. So how many is that altogether? That is 14 out of 20. And 14 out of 20 then simplifies to give you 7 out of 10 if we simplify that by dividing by 2. All right, let's have a look at the next question. In question 2, The digits 5, 6, 8, and 9 are written on cards and put in a bag. 2 cards are drawn at random to make a 2-digit number. For part A, make a list of all possible outcomes. So in this case, what we do is that if there's the numbers 5, 6, 8, and 9, pair up the first 2 first. That's the easiest way. And then if you want to find all possible outcomes, stick that 5 as the first number all the time, and then just pair that up with the next 2, like that. So 58 and then 59. Okay. Then once you're done, make the second number the first digit, and then pair this with each of these other numbers, which are going to be the second digit. 65, 68, 69. And then you repeat. So you start with 8, and then make 85, 86, 89, and then start with 9, and then make 95, 96, and 98. Okay? So for part B, how many 2-digit numbers are possible? Well, we've got 4 columns and 3 rows. So 4 times 3 will be 12 different outcomes. Part C, find as a decimal correct to decimal places the probability that the number is even. So if it's even, that means the last digit or the second digit has to be a number divisible by 2. So it has to be of 0, 2, 4, 6, 8 as the last digit. So the ones that I have to include would be these 2, okay, because 6 and 8 are even. 68 is even, 86 is, 98 is, and 96 is. Okay? So the rest of the numbers have odd numbers as a second digit, so they're not even. So in total, we've got 6 numbers here. And those 6 numbers are out of 12, which is number half. Okay? And this is for part A. I should write that. There we go. Now for part 2, greater than 60. Well, numbers greater than 60 don't include these lot here, which are 50s. So it includes these ones here, 65 and above to 98. So that includes 9 numbers out of 12, which is the same thing as 3/4 if we divide by 4. Now for part 3, between 60 and 90, well, these are between 60 and 90. Okay, these are as well, but these aren't because these are above 90. And by the way, if it says between 60 and 90, it does not include 60 or 90. Okay, so the first number you should accept is 61. The last number you should accept is 89. So in this case, we've got 6 numbers out of 12, which is perfectly half. Then for part 4, we're looking at numbers divisible by 3. Okay, so the easy way to do this is this. Okay, you've learned before in year 7 that numbers divisible by 3. Okay, there's a rule behind that. Okay, so what you do is you add the digits. Then if the digits, or if the sum actually, sorry, if this sum can divide by 3 entirely, then the number can divide by 3. Right, so now, so let's have a look at this. So start with 56. If you add 5 and 6 together, that's 11. 11 cannot divide by 3, so we don't accept that. Let's move on to the next one. 5 plus 8 is 13. 13 cannot divide by 3, so it's not divisible by 3. 5 plus 9, if you add it together, that's 14. 14 can't divide by 3, so no. 6 plus 5, again, is the same as this, so it can't. 6 plus 8 is 14, and 14 can't divide by 3, so nope. 6 plus 9 is 15, and 15 can divide by 3, so I'll accept this one. 8 plus 5 is 13, and 13 can't divide by 5. Oh, sorry, can't divide by 3, so we don't accept that. 8 plus 6 is 14, and 14 can't divide by 3, so we can't accept that. 8 plus 9 is 17, 17 can't divide by 3, so we don't accept that. 95, so 9 plus 5 is 14, 14 can't divide by 3, so we can't accept that. 96, 9 plus 6 is 15, and we can accept that because 15 can divide by 3, and 9 plus 80 is 17, 17 cannot divide by 3, so we can't accept that either. So we only have two numbers that we can accept out of 12, which is 1 out of 6.